Hi, welcome back for some examples. So in the last video, we talked about how to add, subtract, multiply, and use exponents with a complex number. In this video, we're just going to focus on examples for multiplication, okay? The other thing I'm going to do in this video is I'm going to include an example, probably just one, but maybe two. We'll see how the time goes, where we use FOIL instead of double distribute. So for those of you who like to use FOIL, if you skip to the end, that's going to be the last one or the last two examples that I do at the end of the video. If you want to, you can skip right there and you can get some examples on how to use FOIL if you want that. So with that said, let's go ahead and get started. Again, these were what we were focusing on. In the previous video, we learned all of these, but right now we're just going to talk about only multiplication and nothing else. So the process of multiplying was all about using distribution and then dealing with any I squareds or i's that have exponents as they pop up. Okay, so multiplication. Okay, first we deal with the polynomial. First, we treat it like it's a polynomial. And so that means distribute for most of us, distribute. For some of us, that means FOIL. And like I said, at the end of this, we'll do an example of FOIL. So that's where we start. That's the first process that we do. Then we deal with exponents and combining like terms. Okay, so I squareds. All right. So that's our basic idea. That's our basic process for all of these. In the last video, I did an example where we do a multiplication using or multiplying by a real number. All right, so for that, I'm not going to repeat that. It's fairly straightforward. When you multiply by a real number, you just distribute that real number. You don't have to deal with exponents or anything at all. So I'm going to do one more example where I'm distributing an imaginary number. Then I'm going to do one more example with a double distribute, and I'll finish with one example using FOIL. So again, if there's only one of those things that you're looking for, feel free to fast forward the video and get to the spot that you are interested in. So first of all, our first example here, we're going to distribute or multiply using an imaginary number times a complex number. So let's say I distribute a negative 7i times 4 plus, 14, 4 minus, I'm struggling here. Negative 7i, 4 minus 13i. There we go. That's what I'm trying to get. Negative 7i times 4 minus 13i. All right, so there's our first example. So again, the idea is to distribute. So I'm going to distribute that negative 7. And at first, I would do this just like any polynomial. So negative 7i times 4, I'm going to multiply the numbers together. Side note, you know this. You've watched enough of my videos, you know this. You should pause the video and try this on your own first. Now that you've tried it on your own, let's finish. All right, so negative 7i times 4, I'm going to multiply the numbers. So negative 7 times 4 is a negative 28. And then I, there's nothing for the I to multiply with, so it just stays I. And that's my first piece. My second piece, I'm going to have a negative 7 times a negative 13. I'll be honest, I don't know my 7 times tables all the way up to 13. So let's just do that. Negative 7 times negative 13. 91 is what I get there. So a positive 91. And then I times I is I squared. So I've got that. Okay. So that takes care of the polynomial part. That's the distribute part. Now I deal with my exponents by using the fact that I squared is the same as multiplying by negative 1. I squared turns into a negative 1. So what I end up with here is this 91 that was positive is being multiplied by a negative 1. So it's going to become a negative 91. It was positive. Now it's negative. This negative 28i is still there. It hasn't gone away. But notice what's happened now is that my imaginary part and my real part are backwards. In standard form, we put the real part first. This minus sign is part of the real part. They go together. So that minus sign goes with the negative 91 to the front. That's the first piece of putting it in standard form. And then the 28i, that's my imaginary part, it's going to go to the end of my problem, negative 28i. And there's my final answer. Okay, so that's an extra example with multiplying a complex number times an imaginary number. All right, so there's example number one. Example number two, we're going to multiply two complex numbers together. We're going to multiply two complex numbers together. This time I tried to write it without saying it because last time I couldn't do both. All right, so 3 plus 4i times 3 minus 2i. We're going to multiply those together. And in this one, I'm going to use the process of double distribute. That's the process that I like to teach. If you like to use FOIL, skip to example number 3. Okay, so here we're going to do double distribute. Okay, that's what we're going to use right now, double distribute. So pause the video and give that a try on your own first. And once you've finished it, resume the video and let's compare. All right, so hopefully you've tried this. If you're doing it with double distribute, then you took this whole thing as a single unit and you distributed it to the real part and you distributed it to the imaginary part. Okay, that's how you should have started. So when I distribute it to the real part here, I'm going to have a 3 plus 4i, that whole unit, times a 3. Okay. Now, when I distribute to the imaginary part, remember, this is where I like to make a tweak. I don't like to distribute to something that's being subtracted. So I change this into plus a minus 2, plus a negative 2 is what I do. So that lets me keep a plus sign in the middle. And now I can distribute this thing to the negative 2i. So I've got that whole thing as a unit, that whole thing out in front as a unit, and I'm going to multiply that by a negative 2i. And I just think it makes everything much, much more simple if I can keep this a plus sign and I can distribute the negative 2. It makes life more easy for me. So now I do the distribute from those two parts. So 3 times 3, that gives me a 9. 3 times a positive 4i is a positive 12i. I've got this plus sign right here. Negative 2i times a positive 3 is going to be a negative 6i. And a negative 2i times a positive 4i is going to give me a negative 8i squared, right? I times I is going to be I squared, right? So there's my answer after I do the distribution process. Now I'm going to deal with the exponent. I know that I squared is always equal to negative 1. So I'm going to turn that I squared into times negative 1. Everything else is the same. In fact, just to emphasize that, I'm going to write all the rest of this down again right now. There's the 9. There's a positive 12i. There's a plus a negative 6. I'm just going to make that minus 6i if that's okay. And then minus 8. So all of that comes down. The only thing I've changed is I've made the I squared into negative 1. So now these two things can multiply together. Negative 8 times negative 1, that becomes a positive 8, but all the rest of this stays the same. 9 plus 12i minus 6i plus 8. All right, and last I'm ready to combine my parts together. So for my real part, I've got a positive 9 and a positive 8. They combine to give me 17. For my imaginary part, I've got a positive 12i and a negative 6i. They're going to combine together to be a positive 6i, and there is my answer. Okay, so that's my answer when I do the double distribute process. All right, last but not least, let's do a final example where we use FOIL. So here we are on example number 3. Again, double distribute always works. So if you're one of my students who like to use double distribute, if you have been following my suggestion all year long, you can do this problem with double distribute, but your work obviously will look different than mine. And if you're one of those students who have been doing FOIL all along, then you're in luck because this is going to match with what you've been doing. Okay, so we're going to do this one using FOIL is what we're going to do. And when I teach FOIL, or when I used to teach FOIL, I really don't teach it at all anymore. I color code it. So my first, I'm going to do with red. First stands for the things that come first in the parentheses. So that's a 5 and a 3. I'm going to multiply 5 times 3 together. That's my first, 5 times 3, and that's going to give me a 15. Okay, now my O stands for the things that are on the outside of the parentheses. So on the outside, there's a 5, and on the outside here, there's a negative 6i. So I'm going to multiply those together for my outsides. 5 times negative 6 is going to be a negative 30i. For my insides, that's the things that are on the insides of the parentheses. So I'm running out of room down below. I'm going to move up here to the top. So on the inside, so here's the middle, right here in the middle, on the inside of this parenthesis, there's the 2. On the inside of this parenthesis, there's the 3. I'm going to multiply those together for my I. So 2i times 3 is going to be positive 6i. And then last but not least are my lasts. Okay, so the things that come last. So in this parenthesis, the thing that comes last is the 2i. The thing that comes last in this parenthesis is a negative 6i. That's an L for last. So 2 times negative 6 is negative 12. And then I times I is I squared. And so that's what I get after I do FOIL. Now, just like before, not changing anything, I know that I squared turns into a negative 1. So I've got a negative 12 times a negative 1. That's going to equal a positive 12. And the rest of this, I haven't changed yet. It's still there. So I'm just going to drop it all the way down. I've got a 15 minus 30i plus 6i. And then this thing turns into a positive 12. I finished by combining my like terms. A positive 15 and a positive 12 are going to give me a 27. A negative 30i and a positive 6i will leave me with a negative 24i. And there is my answer. Okay, so that's the process using FOIL. All right, so that gives you an extra example of each one of the more difficult multiplication problems. Hopefully you found that helpful. Thanks for watching. If you want more examples with exponents, then stay tuned for that other video. It's coming up next.